The heat engine do work from the input energy from the hot reservoir and then give away some waste in terms of the heat to the cold reservoir or to the environment. We can reverse the process by giving the work into the engine and then transfer heat from the cold reservoir to the hot reservoir. And this kind of engine we call it the heat pump. You can see that we cannot let the heat will not transfer from the cold reservoir to hot reservoir by itself. Normally, if we let the process happen by itself, the heat will transfer or flow from the hot reservoir or the region with higher temperature to the cold reservoir, which is the region with the lower temperature. If we want to reverse the process, we have to input the mechanical work, and the engine that do this work is the heat pump. An example of the heat pump is the refrigerator. The compressor is the one that do the job, that is, you input the engine to the compressor, to the motor in the compressor, and the compressor will pump the heat from the cold reservoir, which is inside the refrigerator that has the lower temperature, and put it to the hot reservoir, which is the environment outside the refrigerator. So in this engine, we use the mechanical work to transfer the heat from the low temperature region to the high temperature region. Okay. Refrigerator is an example of the heat pump. The air conditioner is also the example of the heat pump. Now, the ideal heat pump that the engineer tried to design is the heat pump that can transfer heat from the low temperature region to the high temperature region by itself without the input the mechanical input of the mechanical work. This is the ideal heat pump that we want, but obviously you can see that we cannot have this kind of heat pump. The heat by itself will transfer from the hot or the higher temperature region to the lower temperature region. So we have the second statement of the second law of thermodynamics, that from the experience of the engineer, we found that it is impossible to construct a cyclical machine whose sole effect is to transfer energy continuously by heat from one object to another object at a higher temperature with the input of energy by work. It means that you cannot transfer the heat from the low temperature region to the high temperature region without input the work into the engine. This is what we call the process. The process statement process statement of the second law of thermodynamics. This is a quasi statement of the second law of thermodynamics, and this gives us the impossible direction of the energy transfer. That is, we cannot transfer the energy in the form of heat from the cold region to the hot region without input some mechanical work. Now, the next question is about what is the efficiency of the heat pump. Since we need to input the mechanical energy into the system, the efficiency of the heat pump is the ratio of the heat that we can pump over the work done on the heat pump. However, in the heat pump, there are two kinds of efficiency. We call the efficiency of the heat pump as coefficient of performance, and in short we call it the COP. And we have two modes of COP. First, it is the cooling mode. In the cooling mode, what we want to do, or the main purpose of the heat pump, is to cool this region. It means that to take away the heat from the cold region and put it out to the environment. This is the example of this kind of heat pump is the refrigerator, that you want to cool, to lower the temperature or to keep the low temperature inside the refrigerator. So in the cooling mode, the COP is defined as the heat transfer out of the cold region or the cold reservoir over the work done on the engine. Now, W here is the work done on the engine, because in this system we have to give the mechanical work to the engine. So this is the cooling mode. The efficiency is the number that tells us that how much heat that we can take away from the cold region and compared to the input mechanical work that we have to give to the engine. But we can also have the heat pump in the heating mode. In the heating mode, our purpose is that we want to pump the heat from the cold reservoir. For example, from the environment, we want to pump the heat from the environment to and put it to the hot region. For example, we want to pump the heat from the surrounding air and put it inside the house to warm up the house in the winter. So this is the second mode of the heat pump. Again, the principle is the same, that we want to pump the heat from the cold region and put the heat into the hot region. But in the heating mode, what we want is the higher temperature what we want is the heat that put to the higher temperature region. This is different from the cooling mode. The cooling mode, what we want is to keep the low temperature in the cold region. But the heating mode, we want the heat from the cold region and put it to the hot region. So in the heating mode, the COP is equal to the heat that enter the hot region over the work done by the work done on the engine. Okay, let's correct this term. It should be the Q. It should be the QC here. Okay, it's the heat that take away from the cold region. But the heating mode is the heat that we put into the hot region. Okay, so we have the expression for the coefficient of performance of the heat pump.